Yep, recording is on. And again, welcome to the ESE seminar. This is we do this every semester. We are probably in our third year, starting our third year. And this has turned out to be a very important set of talks. And my reason for talking today is to kind of give you a snapshot of what to expect for the rest of the semester. And the title of my presentation is the Electric Utility Landscape. And there are 3 Ds involved: digitization, decentralization, and decarbonization. So part of your quiz will be to do this 3 times in a row, if you can pronounce those 3 Ds. That's just a joke. Anyway, but these are 3 themes that you'll see in all our seminars, this semester. And, frankly, in all pursuits that the electric utility is going to be setting into. So let me bring my presentation. Let's see, where am I? Okay, I should have been doing this before I got on the air. Okay, hang on, give me a second, so. Okay, if I can share the screen. Susan, do you need to give me permission?
No, you took over as host.
How come I can't see my
Double check, but yeah, you took over. You're the host.
how come I can't see this on my screen?
There's a share screen button at the bottom. Run your cursor over the bottom bar.
I'm not able to do that.
I don't know what to tell you.
All right. Why don't you come on by here and
Okay.
I'm not able to see my screen. Okay.
You're sharing screen.
Why don't you get the other one?
What's that?
Why don't you stop sharing it and see if you can get the other one? Share screen again.
Which one?
You tried this one.
It was there for a moment and then went away.
I'll flip through it. Yeah.
Hmm.
Okay,
Oh,
it's there,
there's a-
Rudy. I see it.
It's there now.
Well, how come it's not on my screen? When I do this, let's see, do you see the, okay. What do you see now? You see the full
We see the
screen?
title slide.
And see this next slide?
Yep.
Yeah, now it's on talk overview.
Okay, well, all right, guys. Well, let's give this another shot. Apologize. I guess this are the little hiccups we get right in the beginning of the semester. Um, Again, the title of my presentation is the Electric Utility Landscape and 3Ds. And I want to kind of, first of all, give you a brief outline. You know, electricity is a critical infrastructure and is going to become even more so as we enter into this era of climate change. Because to reduce carbon is not only in generation of electricity, but we need to take care of having carbon-free generation for other important aspects of our economy, transportation for one, and industries for another. So electricity is going to start playing a very important role, even more important role than it has played in the last 100+ years. So what are the 3Ds? I'll repeat it again: is digitization, decentralization, and decarbonization. And I'll refer to them as 3Ds. There was a paper I wrote with a few students of mine a couple of years ago on power generation trends in 3D. So some made a very interesting title. It was in the Energy Central, so a lot of that is really material that we presented in this paper. And I'll talk a little bit about what are the drivers. Let me get my pointer going. So what are the drivers and why are we in this position, in this situation? And finally, I'll wrap it up with what's the role Lehigh University is playing, and then I'll entertain questions and answers. Again, it'll be for approximately 90 minutes total, split 60-30. I'll probably take less time than 60 minutes, maybe leave more time for questions. So that's the game plan for the day. So electricity and gross domestic product have been very closely tied for the past 100 years. And you see a couple of, you can see two sets of curves, 4 curves in all. And the top two show the gross domestic product for Europe and United States, starting from right after the Great Depression or during the Great Depression to where we are today. And the y-axis is in log scale, so per capita starts off with a number like 10,000 for US and 5,000 for Western Europe. And you can see it steadily rises and it somewhat plateaus out, you know, in our current decade. And no doubt that gross domestic product rise had a lot to do with increasing generation, increasing consumption of electricity. It added to the industrialization of both US and Western Europe for over a century or more. And during the early stages, there was a direct correlation between use of electricity and GDP. And as I said, it started to flatten out in the last 2 or 3 decades. Now, what is very interesting is the same phenomenon is being delayed by maybe 50, 60 years by China and India. And there's one simple reason for that, is because prosperity in both these countries has been accompanied by increasing use of electricity. And so there's no doubt that electricity has played a role in prosperity and will continue to play a role for developing nations, as is demonstrated in China and India. And there's no surprise that China India and the US are now the three largest producers of electricity. And so you can see that it plays a very, very important role in prosperity. So something that we need to keep in mind. We do depend on a diversity of fuels, and the diversity of fuels gives us the reliability that we seek. It gives us the availability that we want and the resilience. And so there's no one silver bullet that will provide all the energy that we need. I mean, that's just a little too risky. So we rely on a number of fuels: coal, natural gas, nuclear, hydro, and others. And this has been kind of the bulwarks or the workhorses for energy generation, not just in the US, but in many other parts of the world too. There may be a bit more of one, less of the other, but there's no doubt that these fuels have been the major fuels for generating electricity. Now, unfortunately, natural gas and coal, which are the mainstays for electricity generation for all these years, we need to be looking at it very closely because of this. The warming projections let us know that we cannot do business as usual. In the past, I'm sorry, in the current state that we're in, we are emitting roughly 50 gigatons carbon dioxide equivalent. And if we don't do anything, the business as usual will continue to increase carbon emissions. And so the world has come to take notice of that. And there are plans to reduce carbon intake, or burning carbon. And that would mean that some of the mainstays of electricity generation are going to go away, going to be weaned away from coal, weaned away from natural gas, and go into cleaner options. It's easier said than done. And this is because of its presence in our economy for over 100 years. It's very difficult to break that habit. But all the predictions in global warming are somewhat dire. The ideal would be to reach no more than a rise of 1.5 degrees centigrade from pre-industrial times. We're talking about 1850 and before. And there have been several strategies enunciated as to how that could be done. But really the most optimistic net zero target, as shown here, it still predicts that the average temperature will be at least 2 degrees, two plus degrees, above what would be desired. Now, you may think, well, 2 degrees does not much, but unfortunately, and it really is becoming increasingly so year upon year, that extreme weather events are going to be part of our lives. And, 5 years ago, 10 years ago, you could look at this scenario as somewhat into the future. That's not the case. It's happening today. We are witnessing it every year. Every year is harder than the previous year. And so we need to be able to not only enjoy, the prosperity that we have enjoyed all these years, but do this without burning carbon. Again, as I said before, easier said than done because habits are very difficult to break. And there's no doubt there's still a lot of fossil fuels still available. So it's very attractive to continue using fossil fuels. So for all these reasons, the 3 Ds I talked about are going to be playing a role in being able to meet that world where we need to use less carbon than we've been using, if not just less carbon, but net zero carbon. We've all set goals. Different countries have different milestones, but definitely by the year 2050 is where we need to have a target of no more than 1.5 to 2 degrees centigrade above pre-industrial levels. So the traditional grid that we had was shown on the left-hand side. It was very linear. You had a load, which was usually consumer. I mean, they were residential and commercial consumers, somewhat far away from where the generation was being done. And, and so it traveled, or the energy traveled over transmission lines and distribution lines and came into your home or a business. And so this was the way it was, way it has been for many years. But it's transitioning to the modern grid, which has not only a more cluttered view, but more communication than we ever had before, just because we need to be able to control the modern grid in a very dynamic ways. So you can ask, what is the pace of change? It's happening. The speed with which it's changing may vary from one country to another. We've heard of countries that have 90 to 95 to 100% renewables. Those are usually very small countries, but they're there. There are other larger countries. We have set a goal in the US to be net zero carbon free by 2050 and to have grid carbon free by 2035, I believe it is. So all the pace of change may vary from one place to another, but there's no doubt that change is not only in the air, but it's happening in every location. What this has brought about is a very customer-centric view. You as a customer, I as a customer, am more able to voice my needs, voice my concerns, to this provider more easily. And there's no doubt the internet has played a large role in this. And the third bullet that I want to talk a little bit about is social equity. It was true in the past that, the dirty power plants affected ones who were not demographically favorable. It would be in poorer sections of the town. There would be more impact on health among these people, because of dirty fuels being burned. So the social equity issue is coming to the fore as we go forward in implementing the 3 Ds of digitization, decentralization, and decarbonization. So what are they? Digitization is something that was somewhat exotic before. But now it's very common because price of computation has decreased tremendously. The Moore's law has been in play. And it's now possible to be able to not only digitize the data, but be able to transport it and have others analyze this. So this can be done very dynamically, instantaneously. And so it's become a big, big asset to be able to improve your operations and maintenance, and also in diagnostics and prognostics. My background in the utility industry was in this area, and I was very fortunate to see these changes manifest in such interesting ways. The utility transformed itself from what was basically a time-based way to maintain assets to something that was condition-based, that is based on what the condition of the asset was, to be able to make a judgment in a timely manner that something needed to be done. And that's because of digital data. Decentralization has really come about, because of global warming. And that has kind of necessitated moving away from carbon-based fuels, which are really large generating stations, to something that could be at the load itself. Solar on the roof, for example, is a classical case where both the supply and the load, the provider and the load, are just, next to each other. And this is going to become more common as we go forward in the decarbonization, where the sources of electricity are going to be very much scattered. You'll have the central generating sites, of course, but you'll also have sites that are spread far away from the load sometimes, and those need to be piped in, to the consumer, to the load, and through transmission lines. So building more transmission lines is one of the things that we'll be facing as we go forward in implementing 3Ds. So I mentioned about digitization is the ability to manage your assets in a more informed manner, and also ability to collate and aggregate information in kind of creative ways to meet demand response, for example, or in some areas which is becoming becoming more and more common, is looking at a product called virtual power plants. I'll talk briefly about that. And again, the third bullet is really telling, and that's really where I had a lot of experience looking at how digital data leads to better diagnostics and prognostics. That is, prognostics would be, how soon should I look at this asset to make sure that it functions well before it really fails? Because I have a good view of what its behavior is going to be 6, 9, 12 months from now. So I need to take action appropriately. Here's an example. What you're seeing in the diagram is an RCP, or a reactor coolant pump, a very important asset in a nuclear power plant. If this were not to work well, it would be disastrous, especially if you don't detect problems soon enough. It has different modes of failure. Failure affects the mode analysis of FEMA. They have this, they can distinguish different how things can fail. They have different modes. Just for example, I've shown that imagine that there are 3 different modes of failure. You could look at these failure signatures and look at how they behave. And there are some anomalies that you detect, you're able to identify that issue that could cause concern and cause you to kind of shut it down. So that before something more serious happens. And this can be done, because of the availability, access of digital data. Now, it's not the data itself is useful, it's how you analyze the data that's becoming more and more prevalent. And that's why you see more machine learning, more artificial intelligence, because of the large, copious amounts of data that are being made available to be able to do things like this. So something so important as the reactor coolant pump, we are assured that you are able to monitor for the different kinds of failures and take appropriate action if some things start to look anomalous. This has, in the past a couple of decades, has led to utilities putting together something called the Power Optimization Center. Not only very important assets like the reactor coolant pump that I showed you, but they can look across their fleet for all their assets on their different ways of generating, the nuclear assets, the coal and natural gas assets, and on and on and on. They're able to bring all this data centrally, and instead of having experts at each location, they're able better to look at in a central manner. In other words, there could be a central place where all this data is put together, but they could call upon experts to look at this information anywhere in this world. I saw a demonstration some time back, which looked very novel, but was very straightforward these days, where I think the demonstration was done by Siemens, where they were looking at some of their advanced turbines using powdered metallurgy, and having some of their experts, not only in Germany, but also in Asia, look at it simultaneously and they were able to discuss test results with our group, which was then in Charlotte, North Carolina. It was it was a very novel way to bring a lot of people together to look at a particular asset that could be very important for operations and make a decision. This was somewhat commonplace today, but was very unique in the previous days. In our seminar series, seminar number 3, you hear about how this was done at one particular utility. This is being done at several utilities around the world, and obviously is going to increase even more as artificial intelligence and machine learning starts to play a big role. Now, as I said, decentralization is the other second leg of the 3Ds. And this has come about because of proliferation of distributed energy resources at consumer sites, i.e. solar panels. They've become very cheap over the years. They have dropped in price a couple of orders of magnitude. Before, to get solar generation at $1 a watt was a pipe dream. It used to be much, much more than that. But now it's very much possible to have solar very distributed. And so that has caused us to look at decentralized generation. And for just for that very reason, not only can the consumer have generation over his head, in a rooftop, but they could have other distributed DERs too. They could have storage that's available. And increasingly, electric vehicles where you're charging your vehicle with electricity rather than using fossil fuels. That is going to become more of a reality in the next couple of decades per administration directives. So you're seeing things that are happening at the customer site, which has kind of blurred the distinction between generator and consumer. In fact, the word prosumer has come about, P-R-O-S-U-M-E-R, which means somebody who consumes and produces at the same time. And again, this third bullet alludes to the fact that by having all the generation and consumption all at one site, the idea of virtual power plants is taking a lot of traction, and I'll talk a little bit about that further down. Again, this graph just shows how growth of solar has been astronomical in the last 20 years or so. And the idea of a virtual power plant has come about where there's several drivers for this. One of the big drivers that first was noticed was the high cost of peak demand. Very hot days, to purchase electricity or obtain electricity is the most expensive per kilowatt hour energy usage that you pay for. In fact, Con Edison, which used peak demand for maybe at no more than 1 week in a year, 7 days in a year, accounted for more than 30% of its budget. So it was roughly $3 billion out of their $10 billion budget that they were used those days for those 7 days. So imagine that if you could do many things. One is, first of all, aggregate all the other assets. You have rooftop assets, you have, potentially in the future, energy in your electric vehicle battery. You have storage capabilities at your home or your in the commercial building. Imagine if you could basically utilize all those as a power plant. How you do that is through the internet, through aggregation, through artificial intelligence. So that's why the term virtual power plant came about. So it's a power plant which is kind of stitched together. When I say stitched together, it's not a laborious process. It's almost an instantaneous process. And you're able to produce the same amount of energy as you would if you were to meet peak demand. So this was a much less expensive way of meeting peak demand. And so that had become the driver. But there are more concrete reasons these days. Now, if you want to meet higher and higher demand, in an urban environment is so difficult because you have to move assets into a dense urban area. And so you see the problem that you're just not able to move goods, through very dense urban areas. So this idea of virtual power plant, building a new substation in Manhattan is unthinkable. In fact, it's not doable at all. So you can avoid that by using something like a virtual power plant that can provide the same kind of capabilities that you had before. And finally, the third D is decarbonization, which has become probably one of the most important of the 3 Ds. And that is where we need to be thinking not only of generating electricity in a carbon-free manner, but also all the things that are done which are carbon intensive, like the making of concrete, the making of cement, driving of transportation is now almost 90+% carbon-based fuels. Just think about the goals for meeting climate change. If you have to be net zero by 2050, which is about 25 years plus, a little more than 25 years from today, imagine none of your vehicles is an internal combustion engine, or that all the cement that's made is carbon free, or all the concrete that is made is carbon free. That's a tall order. And we have to do that to maintain temperatures between 1.5 to 2 degrees centigrade to avoid, the extreme effects of climate change. So electrification now has a larger presence, will have a larger presence, is not only for producing the electricity that drives most of the things, but nearly all of the things that we need to think about. Now, hydrogen is going to play a role, which is carbon-free, but how you generate hydrogen, you're going to be dependent upon electricity again. So you think of the future of electricity, and it's going to be even bigger, much bigger than what it is today. And it had the other burden that it'll have to carry that has to be carbon-free. So it's a very tall order. And that's one of the most important aspects of what decarbonization is going to be all about. And, I'll say this, it's not the technology that is going to be the challenge. It is behavior, human behavior. How we react to change in what we do is going to be much more important than the actual technology that will be driving this decarbonization. How will people adapt, to what they were used to be doing to what they need to be doing? And so you can see that this can be a lot of clashes there. So again, getting back to what the problem is in decarbonization, you can see the pie chart there. The greenhouse gas emissions those are the culprits, as it were. Transportation, electricity generation, industry are kind of almost like 1/3 each, and commercial, residential, and agriculture account for the rest. So right now, our transportation industry and electricity are unfortunately very fossil intensive. So if you got to get rid of fossil fuels in all these 3 big pies, easier said than done, as I said, but that is what we need to set out to do. You can see this one shows, according to Ernst & Young, I believe, EV adoption in different countries. Again, the gist of this graph is that I know the US has made a commitment for electric vehicles by 2035, according to this administration. China and India are following those same trajectory. Their problem, of course, is they're going to come from a very low base to a very high base. It's likely that China and India in 2050 would be the largest producers of cars and they hope that there is going to be heavily electric. So you're going to see this transition in how we drive. It will happen in the next 10, 15 years here in the US, and is likely to happen equally quick rate in other countries too. And China and India are going to continue this through to 2050. The commitments that are made by utilities, unfortunately, don't seem very promising. Again, this is my personal view. If we had to meet this 1.5 degrees centigrade pathway, now what I mean by is a short form of saying that by the year 2050, that we retain temperatures not to exceed 1.5 degrees centigrade of pre-industrial levels. You can see the large utilities are not, it doesn't look promising, is what I can say best. Although next era seems to be the most, and next era and Excel seem to be the most aggressive in going towards decarbonization, it doesn't seem so apparent, with the other utilities. So, the report card is we are falling short of interim goals. Again, it's very. I don't believe it's a technology issue. Technology, of course, does play a role in how we are able to meet these goals. I believe this is more of a behavioral, maybe even political issues that make it difficult. The technology for carbon capture of fossil fuels has unfortunately fallen short. When I say that, again, I'm not alluding to the technology as much as the cost, the economics of capturing carbon as you burn or you consume fossil fuels to generate electricity. And the three largest polluters that we need to pay close attention to, China, US, and India, are not exactly aligned as to how they're going to go about it. Again, there's no overall mandate that says that you ought to do this. Is almost is voluntary. I want to talk a little bit about nuclear energy because I believe this is an area that we, meaning the US, has a lot of experience. It is a clean fuel, is clean energy, and has provided carbon-free energy for 50, 60 years. And I believe that we need to be advancing this more rapidly than even what the current administration is planning to. I think it's a good idea that they're paying attention to nuclear energy, but it's one area that we can, to scale, have large amounts of green, clean energy, without having the amount of new assets that we need to bring in and having them being so far spread out. Nuclear energy is this is a somewhat of a busy graph, but I want you to kind of focus on one thing. On the left pie chart shows the capacity of all the generating capabilities within US as of 2019. I mentioned before, you need to have a diverse set of fuels to make sure reliability and availability are maintained high. But notice the yellow pie, capacity-wise, nuclear is about 10% of our capacity. And look at that, 20% of our energy generation, 20. It's almost double its capacity. Why is that, you ask? Well, for one, nuclear can run 24/7, 365 days. The only time it takes any respite is when you have to put in new fuel. And that fueling outage is usually, it used to be 30 days, 45 days. Nowadays, they can do it in less than a week, and sometimes in less than 2 weeks. So nuclear is playing a much larger role in our generation needs than all the others. And that's because of, as I said, we've maintained nuclear plants for the last 50, 60 years. They've been, at least over the past 2-3 decades, they've been running very efficiently, 90+% capacity factor. That means 90% of the time I can trust that my nuclear plant will be operating and generating electricity. And nuclear plants have a very small footprint, geographical footprint compared to the others. Don't get me wrong, they are big, they occupy a lot of space, but compared to the amount of energy that is available from a nuclear power plant, it is small. And this is where I believe we need to take full advantage of what we have done with nuclear power. We have had a fairly, I would say, a stellar record, safety record. The one accident that we did have was in 1979, the most serious one at 3 Mile Island, not far away. But the consequence of it, thankfully, was quite minimal. It was scary, but was minimal. Of course, since 1979, we've had more serious accidents. We've had Chernobyl, which is mainly due to human error, and in fact, cavalier error, I should say. And of course, the other one, of course, more recently was Fukushima, where the design basis was exceeded by this enormous earthquake and the tsunami that resulted, which flooded the power plant. I think there were 5 units there, well above the design basis, and of course led to a lot of tragedy, unfortunately. But barring those 2 events, it's had a pretty good history, and especially our operation of nuclear power plants has been quite stellar. We have a lot of knowledge, and of course, if there's not much focus on a certain technology, you can see there's this age cliff. There are less people getting into nuclear. But I believe it is time for a renaissance. I believe it's time for us to pay close attention and increase the capabilities of nuclear, looking at advanced nuclear. And I won't go into the details of what they are, but I do believe that it would probably be a very important thing in meeting our 2050 goals of carbon-free generation. If you were to look at a plot of life cycle carbon emissions from selected supply technologies, you have the big hitters, coal and gas off to the left, which obviously are big emitters of carbon dioxide. You can see way out on the right, the best in class, as it were, is nuclear. Even better than traditional renewable energy providers, wind and solar. That's because in the manufacturing of solar photovoltaic cells, the manufacturing turbine blades, the carbon consumption is not zero. So you can see nuclear has a very enviable role in life cycle carbon emissions. The one drawback, of course, of nuclear is waste. I mean, there's no getting away from that. But that waste is managed pretty well here in the US. There were plans to be able to store this at a central site in Nevada. That didn't come about. Again, not because of technology, but I'll leave it at that. But they're still being safely managed at individual plant sites. And even looking forward, there are some advanced nuclear technologies that can look at using the spent fuel from current reactors to be able to utilize that even more, so that you're going to literally have no harmful fuel rods that could be a problem in waste storage. That technology is, in fact, was developed by Bill Gates' organization. And if that shows success, then that could be a very good news for nuclear power in general. So even I think even as we pursue all of the above strategies to decarbonize, I think nuclear energy research must increase. It will be increasing, but I think we need to step it up even more. I think the one very exciting thing that's coming about is small modular reactors, or SMRs. They're in fact LWRs, light water reactors in a can, as it were. And they're very flexible. They come in 3-packs, 6-packs. They're very modular. I think if one thing, the lessons learned from the past 50, 60 years is the more a nuclear plant is factory constructed rather than locally constructed, the less uncertainties there would be as far as what is levelized cost would be. And the more modular it is, there's more standardization as to how you need to be able to fix these things. One of the terrible things about our nuclear fleet was they were all almost, even though there were specific types of nuclear reactors, they were all custom made, and each one was slightly different from the other. With SMRs, there's this promise that it could be a little more standardized. Again, we don't have an SMR in service as yet. Things can go wrong, but I do believe this technology is very promising. And nuclear waste, again, I alluded to this. As much as nuclear waste is well managed and well contained, it's the dangers that nuclear waste provides. It cannot be safely disposed of, for thousands of years. So we're talking about generations in front of us. So something that we do need to take seriously. And as I said, if nuclear waste, the nuclear waste fuel that is stored these days still has almost 90% of its energy still available. And if there are some technologies that can leverage that, that'd be great. Another bit of interesting news, I believe, is I kind of, with a student, we put together, we did a capstone project where we looked at the what would be the cost issues, and if we were to compare, NuScale is a manufacturer of SMRs, and looking at what level would they reach parity with the most popular way to build new plants, combined cycle gas turbines. If the cost of carbon were $10 per ton at a 6% discount rate, you could see that they'd reach parity, whereas it has to be a little higher for private funding, where the discount rate would be 9%. Again, it's a graph that's somewhat complex, but it all goes to show you that if carbon price were priced at $10 a ton, SMRs are very feasible. And $10 a ton, by the way, for those of you who are keeping score, in 2009, when there was a carbon bill that was going to be passed, but failed by one vote, was at $10 a ton. So it's going to be quite different. Putting a price on carbon has been a big issue, and so I believe this. We need to go even below this number for it to be, quote, economical and practical. And the last point about nuclear reactors is that they are located in several parts of the United States, mainly on the east of Mississippi River. Very few out in the west. Even Diablo Canyon, which is out here in California, they had plans to retire it, and it's coming back to life. That's one great story. I believe that they realize that they cannot meet the decarbonization goals, without Diablo Canyon. So it's really good news that they will be resurrecting that. But anyway, this graph just shows that we have not only good long experience, we have varied experience of operating this in different geographic localities. And so we need to take advantage of this as we go forward. So I'm going to wrap up this task by looking at some, even I mentioned our interim goals. We've kind of fallen short. That's not a good message to convey, but that's where we are. And I believe there are 5 difficult tasks. And again, there probably may be more, but I do believe that there are 5 difficult tasks in our transition as we strive towards net zero. Increasing nuclear, I've kind of made a strong point that we ought to be increasing nuclear. But you know, the one thing about nuclear, and all you need is one accident, whether man-made or an act of God. All you need is one accident anywhere in the world, you know, to upset things, because, well, nuclear radiation has no boundaries. And I'll just mention that, you know, this recent war that's going on in Ukraine and Russia. And I know you've probably heard about the Zaporizhzhia nuclear plant. It's one of the largest in Europe. It's Russian design. And it really is remarkable that you can actually fire missiles and get away with it in a nuclear plant. That would be considered something criminal. But you can see that poses a risk that could shut down nuclear, absolutely. And here I'm talking about how much nuclear could be a big savior in us reaching goals. But in increasing nuclear may be difficult to attain. Batteries for long duration storage. I didn't talk too much about renewables, but I just mentioned that, you know, they are proliferating. But one of the things that would make it more possible for them to be in widespread use and lower cost would be for batteries to store the energy so that when the sun is not shining, you're able to generate electricity from the stored energy. Batteries for long duration storage. There's a lot of work being done, but we've got some ways to go. Permitting, again, sometimes the worst enemy of technology is bureaucracy. It was amazing that the FERC has come up with rulings that just turned this upside down in a good way, where permitting that will take so long now is going to be shortened dramatically. It's permitting of renewable energy. It's because you had to build transmission lines, and the person who built the first solar plant would have to, you know, take the burden of building a transmission line. That's all going to change. We need to have education and innovation that is shared equally by utilities and the Public Utility Commission. Again, not to belabor a point, public utilities oversee what utilities can do. By the way, the PUC is made up of people like you and me, so they're not an unknown quantity. So the more they keep abreast of what are the innovations, the more likely you can see innovations being enacted. And even though they're saying the electricity demand may be just about maybe 60, 70% more than what we're using today, I think the demand is going to be much, much more, 2 and 3 times. You know, and this is one area that I agree with Elon Musk. You know, he's come up with the same number. I believe that electricity demand to meet all the challenges from climate change, decarbonization, digitization is going to be much, much more. Are we ready to kind of meet that kind of demand, which is 2x, 3x of what we have today? this is what we do in our program here. We turn out students with a master's degree, looking at all these aspects of where the energy issue is. And our mission is to produce a new generation of world-class leaders for the energy industry. And I'm going to stop right here because we're running out of time, and I want to take questions. I will stop my slides, stop sharing. And all right, so I'm open for questions. So there's a couple of ways you can ask your questions. One is unmute yourself, introduce yourself and ask the question. Or you can put the question on the chat box, and between Susan and I, we'll try to just, see if we can answer your question. So floor is open. I see Alex has his hands raised. Alex, go ahead with your question, please. Unmute yourself.
Yeah, Professor. So with some of the more optimistic projections saying hitting a 2 degrees Celsius rise, I'm sure the more realistic projections are a little bit more grave than that. What can we do in addition to trying to decarbonize to make our societies more resilient for the environmental change that's going to happen and the increased environmental disasters? I've seen projections of the jet stream collapsing and a lot of things like that. So what can we do to make our society more secure as well as net zero?
Wow, Alex, I could spend a lot of time on just this one question, but and I'm sure my views are probably my views. And I keep stressing that technology is not the issue. I believe that behavior is bigger. It'll play a much bigger role. And sometimes it doesn't come across when you say people need to change their behavior. Sometimes people can say that, well, that means we're not being able to live the life that we lead, which may be true, but behavioral changes are always difficult. Consuming less is a nice thing, but easier said than done. In fact, one of our talks, this seminar series, will be from a person in Uruguay. Why Uruguay? Because Uruguay is a country that's 95% carbon-free generation, 95. But it's not a big country like the U.S. But I'm not saying that we should be there today. We cannot be there today because we're too big a country, to make that big change. But they made the change, but they were driven by, their geography was such that they didn't have much natural resources. Uruguay is kind of south of Brazil, and it kind of borders Argentina too. So they're somewhat, they do have the Atlantic Ocean, but nevertheless, they made a change, and they're 95%, and they attribute this change because they were forced to do that. Is that an example of what everybody else ought to do? No. I think leadership needs to be there. U.S. is a big and an important country, and if we take the steps to make the change, the rest of the world will probably make the change too. So I don't know if I answered your question, Alex. I'm not sure technology is the only answer. Hey, listen, if we had nuclear fusion, that may speed up things. But we don't have it, and we don't expect to have it for the next 60, 70 years. So I do believe that making the change is going to be much more behavioral than anything else. I think I half answered your question, Alex.
That's all right. We can talk about it later. Thank you.
Okay.
Any other students with questions?
Unmute yourself, introduce yourself.
I have a quick question.
Oh, go ahead, Ava.
Just looking at, the transition away from coal and looking at communities that have a lot of employment and, they're kind of centered around coal, there's obviously a good amount of pushback there. So what do you think are some avenues with kind of transitioning in those communities and getting those people on board and, increasing employment opportunities if possible?
Wow. Boy, you guys don't ask easy questions, do you? Well, again, the easy answer is retraining, but retraining again is one of those things that are, it's easier said than done. And, if somebody has worked in a power plant and, having been in a power plant for a few years, it's, first of all, it's a very important job. You feel really great that you're providing energy to such an important part of their lives, so, providing them electricity. And if they're used to doing this in a certain way, for them to be doing it in a different way, whether, me operating a boiler in a fossil power plant to somebody managing a solar farm, it's a big cultural change, especially because they're probably at a later stage in their lives, and for them to learn on new tricks, may be difficult, but nevertheless can be done. I think that retraining should be given a lot of attention. And I think the Inflation Reduction Act, and Ava, your capstone project was very much pertinent. There are high incentives. Those that have to be replaced, from fossil fuel-based jobs to nuclear, small modular reactors. It's the incentives for converting, the monetary incentives are huge, if they come to fruition. So that removes one big hurdle, but it cannot be done without adequate, proper retraining. And also encouraging a younger generation to follow suit. Us being somewhat, the last nuclear plant, there was the most recent nuclear plant was commissioned a few months ago, Plant Vogtle, a Southern company. But before that, there was none between for what, 20, 25 years. So, you can imagine you won't have the younger generation interested. I hope SMR encourages people to get into the nuclear field, especially the youth. I think that would be also a strong motivation. I think economic incentives from the Inflation Reduction Act helps, plus retraining of existing workers and promoting education of young students in nuclear technology.
Thank you very much.
Yeah, I don't think I fully answered your question because it was too big.
No, that's
question.
great. That's a great, even if it's just outlining, I think it's a tough thing to accomplish. So that was very helpful. Thank you very much.
Okay. Students, unmute yourself, introduce yourself, and ask me the question.
There are a couple in the chat, Rudy.
All right, let's go for it.
The first one is from, I hope I'm saying her name right, Udemy. She would love to know if there's been research in the area of mitigating possible disasters that may arise from operating nuclear plants. I think you kind of touched on this, but I'm not quite sure if you fully touched on it.
Yeah, nuclear plants. Nuclear plants are, especially in the U.S., have an enormous amount of safety built into it. You know, there's a saying that if you want to have a product that's nuclear capable, it's at least 10 times the cost, you know. And then, again, that's a kind of a, and I'm saying this in a frivolous manner, is because the amount of safety that is always kind of embedded in a nuclear power plant. So I think we take safety very, very seriously. What may be difficult is, you know, if we can emulate, if others can emulate our behavior, you know, our Nuclear Regulatory Commission has got a great reputation in other countries. And I remember in my stint, I used to consult with the International Atomic Energy Agency in Austria. And one of the big attractive features about US participation was how much they wanted to follow the US model in their safety, in their technology. And our safety culture was very, very powerful and strong. And it was because these two bodies were very independent. Safety was quite, you know, NRC is very, very, they're not aligned with the utilities. So they, you know, they can operate very independently. So I think we need to have high regard for safety and kind of replicate, you know, send the message out to others who are contemplating, you know, construction of nuclear power plants. I think that's one good step that the U.S. has taken. Our safety culture is very much appreciated. We ought to be spreading this message. But beyond that, I mean, you cannot control what a XYZ country can do with how they operate nuclear power plants. As I mentioned about Ukraine war, I mean, you know, launching a missile at a nuclear power plant is unheard of. I don't know if I answered your question, Udami.
Yes, you did. Thank you so much. I don't think we have much of nuclear power plants in Africa. I think we basically have only one in South Africa, and I don't even
There's-
think my country ever built one. But it's kind of like something I've been quite interested in due to the enormous power that can be generated. But whenever this issue of building a nuclear power plant came up during my course of study, they always instill this fear in us due to radiation and safety issues and those kind of things. So this kind of like build subconscious fear about the nuclear power plant. So when I saw your webinar, I really wanted to learn more about its operation. Thank you so much. You answered my question.
Yeah, Udami, I do want to mention about small modular reactors. You know, I think if they are more commercial, if they have a history where, you know, it promises to be pretty safe to operate, passively safe, as they call it. It could mean a lot more. I mean, it could kind of infuse a lot more confidence in countries adopting nuclear, because small modular reactors, you know, could be the answer. Anyway, I think they're as I said, they've been built with, you know, with the lessons learned from, you know, from the past, and they're more modular, they're more contained, they're more standardized. So if once they become commercial and we see how they work in practice, it could be a good option for nuclear. I saw a question from Andy.
There's also one from Alexander Vincent, a former ESE grad from 2012. He
Okay.
asked, how can large customer/campus style facilities make the most impact to the 3Ds. Think college campuses, military installations, or corporate campuses like J&J or Armstrong.
Okay. With large about the 3Ds? Okay. Well, we have a capstone project that we've had on our books looking at virtual power plants for Lehigh campus. And that really builds on the idea of looking at all our distributed assets on campus, and how can they be utilized in a kind of an intelligent manner, and aggregating it, looking at artificial intelligence means, utilizing it to manage our demand so that we can answer to demand response during peak demand times. That way we're reducing the consumption of electricity as well as the cost of electricity. I think that would be a nice demonstration project. We've been working on this for about a couple of years, and we want to be able to see if we can implement parts and pieces of a virtual power plant on our campus. By the way, if there's some students out there who are keen on, either past students who have graduated who want to come and do that here, let me know. We'll get it going.
Chung had a question about, he asked, is there a reason why there are so many nuclear plants in the East Coast rather than the West Coast or Central US?
Oh, good question. Well, actually, the load centers are more on the East Coast than they were on the West Coast. That's one. Fewer people in the West Coast than the East Coast or west of the Mississippi. And nuclear plants do need a lot of access to a lot of water. It's a little easier on the East Coast than the West. I mean, when I say the West, places like Colorado is considered the West, but it's nowhere near the ocean, nowhere near major, well, they're near rivers. But you don't need access to water, fewer people. That's probably one big reason. Andy, just to expand on that, many years ago, I guess when nuclear power was still in its infancy here, I mean, they were built a few power plants, but they were just coming up. Canada said that they could build nuclear plants around Lake Ontario, enough of them to supply all the electricity for North America, Canada and the US. And in fact, the phrase "too cheap to meter" came about just from that. They said it would be so inexpensive, it would be too cheap to meter. And we were still paying not very much for electricity, but it's not zero either. Any other questions, comments, thoughts?
Yes, Rudy, this is Hal Long. Thank you for your talk. I really appreciate that. And I can see we have a lot of work to do. Just a question for you and about the school you're in, Lehigh. Some universities have made major commitments to addressing the global climate emergency, like MIT, for instance, where they've asked all the departments to look at how each department and in their courses of study and in their research to address aspects of climate change. Have you seen similar commitment to climate change work at Lehigh? I know your department, your group is certainly forefront in that, but have you seen it elsewhere at Lehigh in other departments where they can also be looking at various aspects of climate change challenge?
Yes, we I wouldn't say we're doing everything that we need to do, but definitely there are other departments. We have an institute called the Institute for ICPI, stands for Institute for Cyber and Physical Infrastructure and Energy. It's a very long, but nevertheless, we're quite involved in a number of DOE, Department of Energy programs that address this. I think in our strategic plan, we address it to the I don't know if it's to the extent that you described that MIT does. But I think that realization, the bigger issue that you bring up very nicely is that I think the universities in some ways need to show how it can be done. So should they play a bigger role? I sure think they should. Things like this virtual power plant is a nice way to show, what can be done by using assets that are somewhat under your nose, are not being utilized, or can, can be cleaner energy. Using less energy is another form of clean energy. So when you talk about improving demand response, in other words, demand response means when there's a high demand, you kind of tailor down your response. Is it somewhat of a sacrifice? But if you are able to do that, you are using less energy, and that's always a good thing.
Yeah, yes, thank you. At MIT, the new president of the university has made it one of their major commitments: climate change, artificial intelligence, and health initiatives. 3 things that the university will focus on in its course, incorporate things into their classroom, incorporate things into laboratory, into the way to think, and also research programs. So it's across the board work. I understand what you're saying, but I wonder if Lehigh has anything where they have where it's one of the major commitments, you might say, to the future.
Well, I think those 3 areas are probably topmost at Lehigh also. Whether it's in that order, I don't know. But definitely, definitely all the students that I run into in Lehigh, they're always concerned about climate. Are we doing the right things? Because ultimately, it's the younger generation that will be living this change. Are we? Can we do more? I'm sure we can.
Thank you.
There's a question. Can you discuss the current status of carbon capture and power generation? Tinku, good question, Tinku. This has been something that Department of Energy, for example, has spent a lot of money. Can I capture carbon that goes out of smokestacks? The short answer is yes, I can. But the short answer that I should pay attention to is that it's so damn expensive. It's not practical. Most forms of generation, they've got to have this nice balance between technology and economics. Coal is great because it's got so much energy density. I can mine for coal. You got a lot of coal. I can burn it. It costs very little. But damn it, I can't capture the carbon once I burn it. They've looked at other aspects. Can I create synthetic fuel from coal? In other words, take the carbon out and then burn it. That can be done, but at a very heavy cost. And Department of Energy did spend at Plant Berry, Southern Company, multi-billion dollars. And unfortunately, that wasn't a good, happy ending either. It can be done, but at a very high cost. There are other plants that is thinking of utilizing the carbon dioxide as the fluid, the working fluid, as it were. The alum plant is being tested in Texas, but again, it's not commercial. Yet to see how will it work in the field. It promises to be pretty interesting. That may be a savior. So anyway, the record so far has been not too attractive. But this is not to say that if you don't have heavier guns, I'd like to see an Exxon or a BP or Shell come into our game because they know much about this. They could help.
Thank you.
Okay. Any other? Susan, I think I've seen all the questions in the chat box.
Yep, we're caught up in the chat box. I just posted about the next seminar and the info session that we have coming up.
Yeah. So I do want to point out the future seminars. As I said, seminar 3 would look into advanced nuclear. That could be something that I mentioned that needs to be promoted even more. And we have several seminars that deal with how do you manage the grid, which has a high penetration of renewables. That's by the CEO of Electric Power Group. The point is, as you increase the number of renewable resources, there could be some crazy behavior on the grid, unexplained as yet. There could be some very large low frequency oscillations. This has been observed at several grids. He'll be making a presentation on that. There's also a presentation on electricity markets that had to deal with the old way of doing business to now a new way of doing business where you're rewarding capacity as much as you're rewarding energy. And we'll have a executive from New York ISO talking about what that market is going to look like in New York in the next 10, 15 years. That'll be a very interesting talk. We have 2 gentlemen from EPRI, Electric Power Research Institute, who'll talk about the transition strategies other countries around the world are adopting to move from a fossil-based generating regime to a zero carbon energy. And it's taking examples like in India or China, what they are doing. And of course, looking at what US is doing. And so once, you have these different strategies being enacted, you can see what works, what doesn't work. And, it could be an example for other countries to emulate. And our final seminar is going to be about the future of nuclear. What are some other promising avenues that nuclear could offer? All right. There's one more question, I believe. Okay, comment, David Ellis, behavior registers as significant in almost every corner of the subject. Yep. All right. Okay, we've got 5 minutes more. So any parting questions before we close the show? All right. Well, thank you again. Appreciate your attention, appreciate your interest. And as I said, we have another 7 seminars which touch upon every aspect of what you heard today, probably in a much clearer fashion, more in-depth too. But I just wanted to kind of lay this as a kind of a framework for some of the things that are going to affect our business, affect how we look at climate change, how we tackle climate change. So I look forward to seeing you at future seminars. Thank you much.
Thank you.
Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Okay, okay, all right.